We've been talking about the 3 Armstrong's axioms and then these 4 inference rules that build on Armstrong's axioms. So reflexivity, which just talks about trivial dependencies and says if y is a subset of x, then of course x can functionally determine y, right? If I know your PeopleSoft ID and your first name and your last name, I can use that to figure out your first name or your last name or your PeopleSoft ID or any combination of those things. And this also means that all attributes functionally determine themselves, right? That x functionally determines x. If I know your phone number, I can use that to figure out your phone number. Okay, this is reflexivity. Trivial dependencies don't really tell us anything new, but it is kind of important for building up some of our other inference rules and axioms and inferring additional functional dependencies. Augmentation allows us to add an attribute to, wait a second. Augmentation allows us to add any attribute to either the determinant or add the same attribute to both the determinant and the dependent. So if x functionally determines y, then it is also true that xz functionally determines y, right? We could add a z to just the determinant, or we could add the same attribute to both the determinant and the dependent, right? And this kind of makes sense because z functionally determines z. We know that through reflexivity. So if x determines y, then it would also be true that xz would determine yz, right? Makes sense? And then transitivity gets a little bit more complex and a little bit more interesting. And this bridges 2 functional dependencies to create a new third functional dependency. In this case, if x determines y and y determines z, then y kind of bridges this gap between x and z, and we could say x functionally determines z. Okay? Our inference rules, union says if a determinant determines 2 dependents independently, then that determinant also determines those 2 dependents together. So if your social security number functionally determines your first name, and your social security number functionally determines your last name, then your social security number can determine your first name and your last name together. Decomposition is just the opposite of that. If a determinant determines 2 dependents together, it also determines those dependents independently. Composition allows us to take 2 functional dependencies and kind of lay them on top of each other. So if A determines B and C determines D, then it's also true that AC together functionally determine BD. Okay? And then my favorite to do and my favorite to say, pseudo-transitivity, is just like transitivity, except one of the functional dependencies is a set of attributes. So if X functionally determines Y and YW determines Z, well now, since X determines Y, anywhere that we see a Y, we could stick an X. So we could say XW functionally determines Z. So I think after assignment 3, which was due just a couple of minutes ago, you guys should be pretty familiar with using these axioms and inference rules. Also, by virtue of completing assignment 3, I hope you're familiar with our normal forms. So first normal form, of course, just says we meet the requirements to be in a relation, that we're all atomic attributes and we don't have any multi-value attributes. In order to be in second normal form, we have to be in first normal form, and also that every non-key attribute is fully functionally dependent on the primary key of the relation. And we really have to consider that any of our candidate keys could be considered the primary key, right? Because we could select any of them, okay? So to be in second normal form, we have to have no partial dependencies. And we can illustrate this in this example here, where we have this relation A, B, C, D, E, and AB functionally determines CD, and then B by itself, which is a key attribute, functionally determines E, which is a non-key attribute. So in this case, AB functionally determines CD is perfectly fine because C and D are non-key attributes that are being functionally determined by the entire primary key. However, B functionally determines E is a problem because E is a non-key attribute that is being functionally determined by a part of this primary key. Okay, that is a partial dependency. Or we could think about this in another way as a key attribute, B, functionally determining a non-key attribute, E. Okay, so second normal form or a violation of second normal form is when we have a partial dependency. And then third normal form says you have to be in second normal form and we have no non-key attributes that are functionally dependent on another non-key attribute. Okay. Now, in this previous example, E, a non-key attribute, is being functionally determined by B, which is a key attribute. Okay. This third normal form violation, or a transitive dependency, is when we have a non-key attribute functionally determined by another non-key attribute. So in this dependency diagram, we have R, S, T, U, and V, and T and U are being functionally determined by R and S, which is a candidate key, and in fact the primary key, because it's our only candidate key. That's perfectly fine because those are two non-key attributes being functionally determined by the entire primary key. However, U functionally determines V is a transitive dependency because this is a non-key attribute being functionally determined by another non-key attribute. And that's a problem, that's a violation of third normal form. So we would take this functional dependency, U determines V, and move that out into another relation. So it would create a new relation with these two attributes, U and V, and that functional dependency, U functionally determines V. That's going to be in another relation, in another table in our database. And then in the source relation, in the original relation, we're going to leave behind the determinant, in this case U, and that's going to now be in that original relation or that source relation, a foreign key that refers to U, which is now a candidate key in the new relation that we just created to resolve this third normal form violation. We also talked about Boyce-Codd normal form, and that we have this fringe case in third normal form where we have a key attribute that functionally determines another non-key or another key attribute, a key attribute that functionally determines another key attribute. So that's not a violation of third normal form, but it does put us in a situation where we might still have some data redundancy. So the things to look out for a Boyce-Codd normal form violation is when we have a relation that has at least two candidate keys and at least two candidate keys that are composite attributes, and that there's some overlap between the attributes that are in these candidate keys. And so this is the example that we had in class the other night. We have this relation XABC, and hopefully just by looking at this, but if not, then by using either our decomposition or synthesis processes, we could identify that we have two candidate keys here. I think the most obvious being XA, because X and A together functionally determine both B and C, but also XB, since B functionally determines A, right? And so in this case, we have three key attributes, X, A, and B, and this functional dependency 3 is not a violation of either first or second or third normal form because both B and A are key attributes. So in order to, we have to be a little bit careful when attempting to resolve this because as we demonstrated in class last time, we can wind up losing some of our data integrity if we select the wrong candidate key as our primary key. So ultimately we want to be in a situation where the determinant in every functional dependency is a superkey in our relation to resolve our BCNF violations. Okay, but BCNF is one of those, or a BCNF violation is one of those things that is kind of a fringe case of third normal form. So typically when we're talking about normalization for business applications, third normal form is kind of the sweet spot that we are looking at.